The rock cycle is often written off as some complicated system that you'd have to spend hours researching to get a grip on. Not to mention sifting through all the crap websites about chakras and healing properties. You've probably just given up and always had to wonder. Well, wonder no longer. Thanks to Mr. J. Farnsworth doing the Googling around for good websites and Josh Studios creating as a video, you no longer need a research degree to learn about rocks. So don't take the opportunity for granted. The first common confusion to get out of the way is rock types and what they mean. There are 3 different types of rocks: igneous, sedimentary, and metamorphic, each of which play an important role in the rock cycle. Igneous rocks are those created when magma or lava cools. Sedimentary rocks are created when sediment compacts or cements over time, and metamorphic rocks are those created when a sedimentary or igneous rock undergoes a change that modifies the chemical makeup or structure, typically through heat and pressure. On a side note, the difference between magma and lava is that magma is underground and is called lava when it reaches the surface, but both are the same substance. The other 2 materials that play a role in the rock cycle are magma and lava, and sediments. These are the 5 different phases of the rock cycle. Alright, well, recording Josh forgot to tell you what a sediment is, so post-production Josh is here to do it. A sediment is a broken down piece of rock that is moved to a new location. Meaning that when material is a part of the rock cycle, it's either one of the 3 types of rock, sediment, or magma or lava. Before we take a look at the processes that cause material to shift phases, it's helpful to know what the rock cycle looks like in order to better understand it. So, we're going to talk about the rock cycle shape and what it means for the nature of geologic processes. As you can see, the rock cycle doesn't go from point A to B to C to D until it gets back to A and repeats itself. Instead, it bounces around in multiple directions. This is known as a nonlinear cycle, as opposed to a linear cycle, which would look like this. The fact that the rock cycle is nonlinear is important to understand because nothing on here has to happen in any specific fashion. It's theoretically possible for some materials to stay as magma/lava or metamorphic rock or any other kind of phase for as long as the Earth sticks around. Material can also change super often in a bunch of random directions. There is no predetermined outcome. With that said, let's finally look at the individual processes that make materials shift between different phases. The most simple and easy to understand of the 5 are cooling and melting. Cooling occurs when magma or lava loses heat, turning into igneous rock, and melting occurs when igneous or metamorphic rock gains heat, turning into magma. The most important thing to note about cooling is that while material can theoretically go its entire existence without ever lithifying, melting, or any other process, magma or lava is the starting point for the rock cycle. So every piece of material in the rock cycle was at one point magma or lava that cooled into an igneous rock. When magma cools, it's called an intrusive igneous rock since it formed below the surface, and when lava cools, it's called an extrusive igneous rock, since it formed on the surface. A slightly more complicated process is weathering and eroding. These are technically 2 separate processes that make up one process. It's like how England, Scotland, Wales, and Northern Ireland are all countries, but at the same time part of a larger country called the United Kingdom. The wording doesn't make any sense, but it doesn't matter. Just go with it. Regardless, weathering is when any type of rock is broken down into smaller pieces, and erosion is when the smaller pieces are moved over time. The ending result is sediment, a collection of smaller pieces separated from what they used to be a part of. The next and most confusing process is lithification, which is an umbrella word that encompasses compaction and cementation, both of which turn sediments into sedimentary rock. When sediments compact, they add up on top of themselves, slowly adding more and more pressure to the bottom. Since the sediments don't fit together naturally, they slowly morph into fitting together as they are compacted in the English sense of the word. And in many cases, instead of air pockets, there will be water that is squeezed out of the forming rock as it crushes together. Sometimes, dissolved minerals are left behind when the water leaves and form a thin coating or film around the sediments, making it easier for them to fit together. When this occurs, instead of compacting, it's called cementing. The final process of the rock cycle is metamorphosing, when sedimentary or igneous rocks are changed in a way that modifies the structure or chemical makeup, typically through heat and pressure. They become metamorphic rocks. The only major importance of metamorphic rocks is that if rocks didn't metamorphosize, sedimentary rocks and sediment would never be able to eventually become anything else, and the rock cycle would be semi-linear.